Okay, so here's our first example. Transpose the following equations to solve for x. So we want to isolate this variable x, and it's in the middle of this equation. So we're going to have to rebalance this equation, rearrange these terms. Okay, so here's our first transposing example. Transpose the following equations to solve for x. And we have y is equal to 5 times, in brackets, x plus 3. So the idea here is that we want to isolate this x term, which is in the middle of the equation. So we're going to have to rearrange this equation to isolate for x through a process that balances this equation at the same time. Now I have listed over here some BEDMAS rules. Our order of operation rules, which we have the acronym BEDMAS for. So we do brackets first, then exponents, then division and multiplication are done, and then addition and subtraction. And that's the order of operations that we stand by when we do this equation, when we work through equations. Now, when we're trying to rebalance or rearrange an equation, it's often wise that instead of working forward like we would normally do through this order of operations, what we're going to do is actually work backwards. So to rearrange, we'll often think of this in terms of the order of operations and then flip it around and do the inverse. So that's the first tool we're going to be going over. Tool 1 is to do the inverse of the order of operations, or all of the operations while considering the order of operations. So to make this make more sense, let's just apply this in this example. So what we would be doing if we were to work forward through this example, we would do brackets first. So we would have had our x plus 3 terms in brackets. So we would have done brackets first. And that would have been adding 3 to x for that x plus 3 term that we see right here. That would have been our first step, going forward through the order of operations. And then what we would do, we have no exponents, so we can ignore exponents. We would have been doing division and multiplication. So we have multiplication by 5 right here. And then we have no additional addition or subtraction. There's nothing over here. So we can ignore those as well. Okay, so this is a pretty basic problem, all in all, compared to some of the ones we're going to get to. Now, the idea here is that we're going to reverse this process to move things over to the opposite side of the equation. You have to work opposite the original order of operations. So now we're going to reverse this process, put that in blue, and we're going to do the opposite of multiplying by 5. We are going to divide by 5. So now we're going to divide both sides by 5. And so what this gets me is y divided by 5 is equal to, and these 5's cancel each other out by division, is equal to x plus 3. And I can now ignore those brackets because it's the only thing on the right side of the equation. Now, step 2 is going to be the opposite of adding 3 to x, will be subtracting 3 from x. So I'm going to subtract 3 from both sides, so minus 3 and minus 3. So that on the left-hand side, I have y over 5 minus 3 is equal to, and we have 3 minus 3 here, which cancel each other out, is equal to x. So now I have isolated x. If I want to have x on the left-hand side, I can simply go x is equal to y over 5 minus 3. And there's my final answer. Let's try another example now.